Okay, part A is actually not a fundamental theorem of calculus question, but it follows from fundamental theorem of calculus. It's testing you on the properties of integrals, especially additivity, or mainly additivity. So it's asking me a question about the integral from -6 to -2, but I don't have any idea what the graph looks like between -6 and -2. I don't have that information handy, so I can't really figure out that integral directly. Luckily, they gave me this piece of information about the integral from -6 to 5, and I have the ability to figure out the integral from -2 to 5 because I have a picture of that graph. So what I know is that if I take the integral from -6 to -2, that's what I want to find out. I know that if I add to that integral, the integral from -2 to 5, which I can figure out by looking at area between that graph and the curve, I'm going to get the integral from -6 to 5. And I know what the integral from -6 to 5 is because they gave me that as 7. And I'm trying to find the integral from -6 to -2. And then I'm going to use area to find this part, the integral from -2 to 5. So what I notice first is that this triangle and this triangle are the same size. One is above the x-axis, one is below. So I don't have any area that is accumulating yet. I also see that this triangle and this triangle are the same size. So they're also going to cancel out. And then I'm going to look at this trapezoid shape. And there's more than one way to get the answer to the area of that trapezoid shape. But one way that I see is that it's a trapezoid. The two bases are 1 and 3. And the height is 1. So the area of that trapezoid is 2. The other way you could do it is imagine taking this triangle here and moving it here, and so you have an area of 2 as a rectangle. So I have that trapezoid as 2, and then I'm going to look at this area here, which is the area underneath a quarter circle. So it's not the quarter circle area, but it's a kind of, if I draw in this square here, it's the square minus the quarter circle. So the square would be 9, and the quarter circle, because it's a radius of 3, would be pi times 3 squared divided by 4. So if I add that on, I have plus 9 minus 9 pi over 4. And so the College Board would not accept that as a final answer, but they would accept it if you move this stuff over, and you don't even really have to do the arithmetic, but it's not that hard of arithmetic. So we're going to subtract 11, so we'd have -4, and we're going to add 9 pi over 4, and that's the part A response.